Okay, let's talk about acid nomenclature, meaning the interconversion between acid formulas and acid names. Now, acid nomenclature is a lot easier if you have a grasp on ion nomenclature because it is based on ion nomenclature. Okay, so acid nomenclature is really tied to anion nomenclature, so the negative ions. And that's because acids are substances that when you put them in water, they release hydrogen ions, so H plus. So that's a constant thing. No matter what acid you're talking about, all of them release H plus. But the difference between acids is what anion is left behind. Okay, so the foundation of the name of an acid is from that anion's name. Okay, so if you have a good grasp on anion nomenclature, or if at least you have a resource that you can look up these anion names, okay, if you're comfortable with finding these, figuring these out, then you should be able to easily convert them to the acid's name. Okay, and so you do that by using three rules. Okay, so there's a systematic to all of this. So what you would need to do is focus on what's the anion that's contained in this acid, or the anion that's left behind when it releases its H pluses. And you pay attention to the suffix, okay? Because anions have three different suffixes. Okay, when you name an anion, it either ends in "ide" ion, or "ite" ion, or "ate" ion. Okay, so it has an IDE, ITE, ATE ending. Okay, the ITE and ATE are when you have oxoanions. The IDE is most often when you have monatomic anions. Okay, there are a few oddball polyatomics that have "ide." Um, but basically, if you can figure out which one of those you have, you take the name of that anion and you just swap out the suffix for a different one, and sometimes you add a prefix. So if you have an anion that has the IDE ending, what you're going to do is you're going to take that anion name, you're going to add the prefix hydro, and you're going to swap out the IDE ion ending for ic acid. Okay? And then if you have an anion that has an "ite" ion ending, you're going to swap "ite" ion out for us acid. Okay. And if it's an AT ending, you change the "ate" ion into "ic" acid. So it's three rules, it's three transitions. And you can use these same three rules to jump from an acid name back to the formula of the acid if you can work out what the anion is. Okay, so you should be able to utilize this forward and backwards to get to the anion or get to the acid. Okay, I've got a table here that gives you some common ones. So the formulas with the names, and you can look at these and you can see kind of patterns in the names. You've got hydroic acid, hydroic acid, hydroic acid, hydroic acid, right? So all of those must be associated with some anion that has an "ide" ending, right? Well, HF has fluoride ion in there. HCl has chloride ion. HI has iodide ion. H2S has sulfide ion in there. Okay. Whereas others you'll see don't have a hydro prefix but have "ic acid, ic acid, ic acid, ic acid," and so on. Okay, have just the "ic" endings. And those all relate to anions that have ATE endings. And so if you look at those formulas of those, you've got CO3, well, that's carbonate ion. NO3, that's nitrate ion. SO4, that comes from sulfate ion, and ClO4, that one's actually perchlorate, because notice this has a prefix of per that carries over from the anion. So that's from perchlorate. And then we've got what, ClO3, that's chlorate ion. Okay, so all you're doing is swapping out endings, and so they're tied together. So when you look at an acid name, or if you look at an acid formula, you should focus on what is the anion, okay? Or what is the ending of this name, and what would it swap out to figure out my anion. And then you can work out the formula or the name, whichever direction you're going. So what we're going to do is we're going to go through a lot of examples on this, just so you can see how to utilize this kind of systematic to interconvert between acid formulas and names, both directions. But before we go directly to the acid names or the acid formulas, I just want to show you the connection between the ions and the acids. Okay, because the other thing you need to realize is you kind of apply the same thing you do for building formulas of ionic compounds. When you combine the anion with H+, it's going to be in a ratio to make a neutral substance, okay? Or when you split it apart, the charges are related to it being overall neutral when it's combined. So let's first focus on some anions. So I've got a list of anions here. All of these anions are anions that could be part of acids when they're combined with H+. And so I'm going to go through and just show how the systematic of the anion name matches the acid name, okay? So first what we'll do is we'll take these anions and we'll write the names of them. So Cl- is chloride ion. And Cn- is cyanide ion. And SO3 2- is sulfite ion. And SO4 2- is sulfate ion. And BrO4- is perchromate ion. And if you work with these a lot, you'll just know them off the top of your head eventually. But you can always use a resource. I would recommend use an organized resource. If you find something that is organized in a nice table, showing you the patterns, and use that resource. And after you keep going back to it, then you start getting these. So we have the names of these. And so what we can do is we can convert those names to the corresponding acid name. But first, I'm going to write down the corresponding acid formula, okay? So maybe I should label this table. This is the anion, sorry, the anion formula. My writing is pretty poor on this. That's okay. And this is the anion name, okay? And let's write down what the acid formula would be. So the corresponding acid, the acid that when it's put into water, it releases H+ and it leaves behind these anions, okay? And so how I backtrack that from the anion is I just combine each of these anions with H+ in a ratio to make it neutral. So if I combine H+ with Cl-, I can combine them 1 to 1 and it makes it neutral. So that's going to correspond to HCl. Whereas Cn-, that's also going to combine in a 1 to 1 ratio because H+ and Cn- will make a neutral compound. Okay. Whereas then the SO3 2-, I have a +1 for the H+ and a 2- for the SO3. So I'm actually going to need 2 of the H+. So I'm going to have 2 H's with 1 SO3. Similarly, the SO4 2 minus, that 2 minus charge is going to be balanced out by taking two H pluses, so I'll have H2SO4. And then the BrO4 minus, that's a 1 minus, so I can combine it with 1H plus, so it would be HBrO4. So these would be the acids that relate to those given anions, right? And if I wanted to name those acids, I need to look at the anion names. Okay, and so I would look at these anion names and look at the endings. So I have "-ide" ion, right? And here I have "-ide" ion. And so those are the only two in this table that have that "-ide" ending. And so what I do to convert to the name of the acid is I take what's there, I add the prefix hydro, okay? So hydro, and then I take everything but the "-ide" ending, so hydrochlor, and then I change that to "-ic" acid. Okay? And then I do the same with the other. I add the hydro prefix, and I take this cyan, and then I tack on "-ic" acid. Okay? And so then that, I have "-ide" ion goes to hydro"-ic" acid. Okay? And then hydro"-ic" acid again. Okay, so that's one of our kind of rules to transition between. The next one involves if you have an "-ite" ion ending. If I have "-ite" ion, that changes to "-us." Okay, so I would have sulfurous acid. Now this one, you might, if you directly convert it, you'll get sulfus acid. Usually people, they wouldn't call it sulfus acid, that just sounds weird. So we call it sulfurous, and so we add back in the UR. This is technically the correct, this is kind of the direct conversion. If you said sulfus acid, usually people would know what you're talking about. They would just correct you and say, well, it's sulfurous. And then we can do the same type of thing. And so again, the "-ite" goes to "-us" acid. Then we've got the next ones have "-ate" ion at the end, right? And the "-ate" goes to "-ic" acid. Okay, so the sulfate is going to go to sulfic, but we do tack in those extra letters to make it sound a little better. Sulfuric acid. Okay, and then same for this other one, we would take everything but that "-ate" ion ending, so per brom, and add "-ic" acid to the end. And so that's just applying those rules to convert the name of the anion to the name of the acid. And so that's a little unusual way to look at it, just because we're usually not talking about the anion. We're actually directly given either the acid formula or the acid name. So you need to be able to jump between these last two kind of columns here. Okay, but to do that, it's helpful to have that other information. So that's why I wanted to walk through it that way first. But let's look at it, in a more normal way, as given the actual acid information. So if we're given the acid formulas, what I would suggest, at least when you're trying to get familiar with this stuff at first, is that you break it up. And so you break it up into H plus and the anion. Now the H plus is the same for all of them, so I won't write that down. I will write down the anion formula. So if I split up HI, then the anion that's in there is I minus, right? Because there's H plus and there's I minus. And then the next one, if I take H plus off of there, what's left, the anion, is NO3 minus. And then the next one, that H2SO3 can release two H pluses, and so what's left then would be SO3 2 minus. And then that last one, HBRO4, that can release H plus, and what's left is BRO4 minus. Okay, so those are the anions associated with those acids. And so then once I know the anions, I would name them. And so I minus is iodide ion, and then NO3 minus is nitrate ion. SO3 2 minus is sulfite ion, and BRO4 minus is perbromate ion. Okay, so you really have to have a good grasp on ions, okay? Splitting things into ions and naming them. That will help you do these interconversions instead of trying to just memorize acid names. So then we can just focus on the endings of these things and do our interchanges. So we have ide ion here, we have 8 ion, we have ite ion, and 8 ion. And so we'll go through and convert those. If I have ide ion, remember that transitions to hydro and ic acid. So hydroiodic acid. And then the 8 ending changes to ic. So that would be nitric acid. And then the ite ion changes to us. And this is one of the oddballs that we tack back in our couple extra letters. So sulfurous acid. And then an 8 ending changes to ic, so per ic. And I think a couple of those were repeats, but that's okay. We were looking at it kind of if you started with something a little bit different. So that's the idea. This is a good way to think about it when you're trying to convert those. Again, like I said, so you don't have to memorize all of these acid names. If you know the patterns, you know, what's the foundation of the name, where does it come from, then you should be able to name any acid. Okay? Let's look at other direction. If you're given the name, you need to come up with the formula. Okay, so what I would suggest there is you're going to completely reverse the process. If you have the name of the acid, I would convert it to the name of the anion. Okay, so focus on what are your endings. So we have us acid, we have ic acid, we have ic acid, and we have us acid. So the ics, pay attention, is there a hydro prefix? And this one, yes, there is. So that's important as well. So the OUS endings simply change to ITE. So we have here the first one, we would have hypoiodite ion. Okay, and then this would be carbonate ion because the ic is 8. And then hydroic turns into ide, so that would be sulfide ion. So again, since we're going the other way with the sulfur, we re-drop the UR part because we wouldn't say sulfuride. And we have the OUS changes to ite, so that would be phosphite. That's another one where, look at that, a couple letters disappeared. So if you said phosphorite ion, I guess it's understandable, but it's not really correct. Okay, so now we have those ion names, okay, and then you need the ion formulas. So hypoiodite ion is IO minus. So you have to have a good grasp on these ions, or you have to be able to look them up quickly. Carbonate ion would be CO3 2 minus, sulfide ion would be S2 minus, and phosphite ion would be PO3 3 minus. And so then to get the acid formula, you would just combine each of those with enough H plus to get a neutral substance. Okay. And so be HIO, you only need one H plus to balance that out. And then the next one we would need 2 to balance out the 2 minus. So we would get H2CO3. And then for the S2 minus, we also need 2, so it would be H2S. And then for the PO3 minus, we would need 3. So it would be H3PO3. And so this is the acid name that's given here. And this is the acid formula. So most often, that's what you're trying to do, is just convert between those two, one direction or the other. So you don't really want the anion, but it's the foundation for the naming system. So it's helpful to stop and figure that out. You don't have to, but it's a good way to understand that systematic and utilize it without having to look everything up.